Good afternoon, all. Welcome to DBI Virtual Extension. I am Ishan Mehta, your host for the today's session. By profession, I am mechanical engineer with experience in VDC and digital consulting business. I am also BSI certified BIM practitioner. I am representing Digitra. We are Patreon and member of CDCP since its inception. Before we jump deeper into this webinar, let me give you a brief on CDCP India and what we are really trying to do. So, as we all know, India is currently executing a huge $1.4 trillion infrastructure vision anchored by Gati Shakti. To transform this vision into reality, our industry must move beyond the fragmented and traditional workflow. CDCP India, functioning as Building Smart India chapter, is a vendor neutral, not to profit society dedicated to this transformation. Our mission is to inspire and collaborate across the AEC sector to advance digitally enabled processes and open technologies. We serve as critical confederation, partnering with government, academia, and global bodies to stabilize the regulatory framework, ISO 19650 standards, and Open BIM by facilitating skill development and developing the national capabilities. However, as we work achieving our economic goals, we must also ensure that we don't repeat the mistakes which other countries has done in past during their developing stages. The picture clearly shows the air pollution is major problem across the majority city of India. And if we don't control it now, we may have permanent damages. Interestingly, if you see, COVID also taught us that if we stop everything, Mother Nature can heal herself, but it is not the viable option. Hence, we have to build, but build responsibly. Without getting much into details, data also confirm that more than 20% of major duct pollution is coming from construction. This has been also recognized by government level. We have also seen some recent talks about leveraging precast for the same. To give us real insight on how we are managing precast deliveries in our country, we have Mr. Amit Barde, who leads the precast initiative at L&T. Amit is licensed professional engineer and lead certified professional. He brings global expertise in structural analysis and precast design for massive residential, industrial, and data center projects. His vision, knowledge of his deep knowledge of international design codes ensures that India's infrastructure meet the world-class standards. So Amit, over to you. And audience, if you have any question during the session, keep posting it and we will pick them up during Q&A session.
Yeah, so good afternoon, everyone. Just quickly checking if you can see my screen now, full screen presentation, and you can hear me well, right, Ishan?
Yeah.
Okay. All right. So, thank you very much to CDCP for the opportunity. It's a pleasure to be here. Ishan mentioned about COVID and online presentations have become a norm since then. Of course, the face-to-face interaction gets missed out, but it works wonderfully in terms of reaching a lot more audience and clarity. So I'm looking at about, let's say, 40 minutes of talk and then interaction, whatever way we have. We will keep the questions, and I think Ishan and all, we can handle that. The talk today will revolve around technology as well as digitalization, and that's the topic name also has been is the digital ways in precast. And what I'm going to do is just to give you a flavor in precast what we are doing, why we are doing. That's the first part, and then I will tie in saying how that digitalization is helping the technology itself. For some reason my mic was muted. Could you hear? Can you hear me now?
Yeah, I can hear you.
Okay, I just got that message. So yeah, precast is not new. One of the very recent memories now that most of us have cherished is the T20 World Cup match, which happened at Shri Narendra Modi Motera Stadium, and this is what is in picture. It is built in total precast. It's a fascinating structure, one of the largest stadiums, cricket stadiums in India. And you see in the picture very unique Y columns and stadium seatings, and the entire structure is being built in precast. What you see in this picture is our high-speed railway project that I think we are almost 75% done now. The girder in the photo is about 40-meter long. It is about 1,000 tons. And if you talk to anybody on that site, they are more proud about that straddle carrier, the blue structure that you see, which was built in India, than the girder. The girder is a mainstream business for them. So day to day, they do thousands. But the straddle carrier was built in house to handle that 1,000-ton element as if it was a piece of cake. So that's where precast has evolved in infrastructure, right? Another project, if I have to show you, this is our Atal Setu bridge in Mumbai, which connects Mumbai and Navi Mumbai, one of the longest sea bridges. And it's done in partial. I think it's precast plus there are some segments which are steel, right? So that's where that technology is coming, where we are building the speed. And if I have to give you a scale on that speed, what you see is a steel girder. It's an we call it OSD, which is orthotropic steel deck. Because of that span, it's about 150-meter long, about 12-meter wide, and weighs about 2,500 tons. Right, and if you want to relate it to the scale, you zoom in that red box, and now look at that picture again. It's just a couple of people standing, and now look at the picture again. It's a 1 football field wide barge, and it comes on that barge floating and gets installed. And what used to take months to do this kind of construction, this one element, and especially this one, I was there standing, and in just about 2 to 2.5 hours, that whole thing was installed, which is a productivity of about 500 to 600 times than what we have done traditionally. So that precast has been used mainstream. What the precast technology, what we are going to talk today is about buildings, and which is new, right? In building space, may it be commercial or residential, we have not done as much, and that demand is coming. We started, L&T started precast initiative in about 2010, and this was in anticipation of that housing demand that was coming, right? And then the housing for all was announced in 2014, and since then we have been building, and that demand keeps going up. And this is why before us, I think there were very few parties, but now there is mainstream demand is coming. In fact, after COVID, we are seeing that interest in building faster, one, building quality, two, where we used to go and knock the doors of clients saying precast systems are available for your buildings, you can build faster, better. After COVID, it has turned the table where it is going to that pull demand, where clients are coming and asking that I want to do it in precast. You tell us what we can do, or the drawings are being generated in precast itself, right? So projects like this housing, why do we do it now? Why suddenly in 2010 we decided that to go for the technology, and of course steel construction is also there. That why is, I think India is rapidly changing, right? If you see, our construction business always lags in terms of technology. 2G, 3G, 4G has happened in just a decade. But if you look at construction for last 40, 50 years, especially building construction, we have been kind of lethargic. The inertia is there, where there is a little reluctance to change into the technology. But last decade, we have seen, even in fact in L&T, if you see on the screen, if I have to do that excellence in construction, our mantra for last 10 years has been that I have to mechanize and I have to digitalize, right? These two have been there. All our engineers, all our senior management and people, the focus is on that, right? And a lot of times it gets looked at as buzzwords, right? Because we are in that AI word, and you are just knocking these words up saying we are going to do that. But the idea behind is, if you want to complete that circle of business excellence, the mechanization is giving me the efficiency, right? The speed, in terms of the skilled workforce, the challenges. We don't have people anymore what we used to have. We still have a lot of people, but not the skilled people or not the people who would want to work in construction. There are a lot many better opportunities available. So we have been facing that crunch where we don't have people. So that mechanization is giving me that efficiency, improving my productivity, reducing the wastage. And that kind of gets measured by digitalization, right? So we have now sensors, we have equipment where earlier we used to build reports and now it's real time. It is telling me that how often my batching plant is used or how often the crane is busy. If it was busy, then what kind of load it was lifting and how much time it took to place that load, and all that kind of information is being gathered. And that gives me a further choice. Okay, then what is the next way to innovate, and then further mechanization. And that's what that cycle is, what we are looking at. And how we go about it is you keep repeating that cycle every time you do something different, do more mechanization, see what efficiency, measure the efficiency, innovate further. That continuous marginal improvement is what we are going to see in this. And this is where all these modern technologies we are being discussing. So if I take this example of residential buildings, if you see conventional formwork we've been using for last 30-40 years. In the 90s, 2000, we tried tunnel formwork. Then we moved to aluminum formwork. So if you see 10, 15, 20 years, the system stay, and then only we change it. 2002 onwards, aluminum formwork in residential buildings has been one of the mainstream systems. 95% of the buildings that we do in L&T in residential are being built using aluminum formwork. And of course, from 2010 onwards, now we are doing precast, about 10 years into it, to see it's right at that cusp where we can do projects like these. So what are the benchmarks? If I have to tell you this, we did couple of benchmarks, what we call it mission within the company. And this one building, it's an actual photo of the building in one of the ongoing projects, which is about 12-story tall. It has about 96 flats, 8 flats per floor. And the whole building, including finishing everything, including the elevators to hand over to the client, was done in 96 days. Right? This is where these technologies are coming into picture. What will take months, we can probably do much faster if you have these technologies in place, the mechanization in place, right? So 96 flats or 96 days, we call it mission 96. But if you see the structure itself, what was built in precast technology, that was completed in just 36 days, right? So a cycle time, what we call it, is a time required for each floor. It's traditionally construction about 15 days or so on paper. Comparative in our precast projects we have operating is about 8 to 9 days. And this we wanted to showcase, saying if I add resources, if I give my best, how fast I can build is about 3 days per floor. And the 3-day number was not important. What was actually more important to us was the first floor itself was done in exactly 3 days. And then each floor, all 12 floors exactly were built in the 3 days. And that's very unique in construction because of the site challenges and all. To perform consistently is one of the biggest engineering challenges these days. And we were able to showcase that, okay, if you give the resources, because most of the work is already done at the factory and built to the site, we can control it much better and we can deliver. That assured delivery is probably of more importance here than the speed itself. With precast, the speed is given. If you switch another, this was done about 6-8 months ago, is what you see in the picture is a MLCP parking structure, about 350 car parks. It's a ground plus 6-story structure, about 1.4 lakh square foot built up area. And this entire structure, whatever that you see in the picture, including the painting, was finished in just 41 days. Right? Now this structure is an MLCP, but you put it's a beam column and hollow core slabs, long span slabs. We can build it faster, about 2,000 elements total. If I put a wall panel, it becomes a school. If I put a glass facade, it becomes a commercial building. If I put an insulated panel, it could become a data center. So the two major systems in our building constructions is wall construction and beam column construction, and we have adopted precast in that both systems. And where we are there now is we are ready to do projects. These projects like these, like mass housing scales. This is the ongoing project in Mumbai. Large project, right? This is about 7,500 units, two types. we have about 66 buildings, and the math that came in this technology, at peak we were doing about 30 floors per month, 8 flats per day, right? And these buildings are not, it is a social housing scheme under PMAY, but from day one, the client and the architects were very clear. It's by architect Hafiz Contractor. We want signature buildings, we want livable and long lasting buildings, and this is what is standing, right? We are now delivering large housing scale. What you see in these pictures are all total precast buildings except the foundation and the first floor, but buildings are standing, different buildings. The left side one building is that Mission 96 building, what we finished in 96 days. But you look at the scale, and this, whatever, at least 30 to 50% of productivity improvement in terms of time. And we have come up to a scale, we are now building taller buildings. These are, of course, about 20-story tall buildings. We have already built 23-story tall buildings. We are looking at now even 35-story tall buildings using this system. So projects like this, we already have a repeat project now. So about 11,000 houses in the same system. We have set up a separate factory and take it up so that we can improve that scale and demand. Some other examples, this is that first building. Like I said, we have been in this space about 10 years, and this was done in 2012. It was one of our first projects in Mumbai. It's a 23-story tall building. The pictures show 3 buildings, but we have built 6 there, about 2,000 houses. And what you see in the picture is a total precast. So including the lifts, the staircases, the chajjas, the external spandrels, everything is in precast. We did another project later in 2014-16 timeframe in Bangalore, again residential buildings, about 3,500 flats, right? And what we are doing is, if you look at this picture in particular, the end user doesn't care what technology you use, right? They have to have their home, which is one of their largest investments for the life. For most Indians, it is your home. If you see the building, the detailing, the look, touch, feel is exactly similar to what kind of buildings that you will get. The same chajjas, the balconies, the finishing, the overall building construction. When they come, and usually we have this tendency to knock the wall and see, right? People are very comfortable with RCC. So same systems you get. The finished buildings don't look any different, except some minute detailing would be there in terms of the joints and finishing and all that, the way we do the architectural treatments. But not only external, even internal. Like we did the sample flats also using the precast, and not even our own engineers. If you see the empty flat also, they will not be able to tell where these joints were. So extreme focus on engineering and detailing, where your system once delivered will be very similar to what they see. Some other projects like hostel buildings, parking structures. This is a parking structure in Mumbai near Terminal 1. Warehouses. This is IKEA in Mumbai. It's a very unique, it's a hollow core slab system. It's a warehouse with about 750 kg per square meter load, and the span is about 16 meters. It's one of the longest spans, heaviest loaded slab. And the best benefit, if you see the left side top picture, at 16-meter span and about 8.5 floor to floor, we didn't need to do any shoring. Right, the slabs were just kept without storing and then install, and that's the best advantage you'll get in precast. We are doing a lot of, this is one project in Hyderabad, that entire facade that you see is total precast systems, right? So inside core is steel and RC structure, and then cladded from outside, where you get a much better finish, direct painting, and buildings look good. In factory space, the electrical switchgear buildings, this is for Reliance in Jamnagar for their solar factory. It's a total precast, what you see in the picture. Same way, we had one glass factory where we do a lot of hybrid work, right? We are finally contractors. We are not a precast manufacturer or RCC structure cast in place, wherever it makes sense. So in this job, you see the linear building on your left-hand side, and it had about 1,500 columns, tall 11-meter columns. So you have to do a lot of shoring, shuttering in place to get that 11-meter up. So the only columns were changed to precast quickly. They were built on ground, installed, and then we finished the structure. Same way, substation buildings. These are some of the substation buildings that we are doing. Total precast, they get that productivity benefit, long-lasting buildings in place. Stadiums, Motera, of course, I showed. We have taken now. Varanasi Cricket Stadium will come inaugurated in maybe a couple of weeks now. That has a lot of precast work. You will see the full stadium. This is about 2 months old photo. Once it's launched, then the official photos will go in circulation. But very ideal situation where now we have standardized enough where all stadiums can be done in precast very quickly. Right. We do a lot of hybrid work also wherever it makes sense to do precast where it will save me some time and take it up. Lot of products. Left hand side is your Navi Mumbai new international airport. It had a 15-kilometer long compound wall, like security fence, what they call it. And it was already in precast by definition or by tender. But we have traditionally done the precast planks. We said instead of plank, we will cast the one full height wall and then place it. Right. So 15-kilometer, it had 20,000 planks. We combined 4 planks to make one wall. The 20,000 elements became 5,000 to install. It's much quicker and doing it. Facade, I mentioned, we are slowly looking at even pre-painted facade where site activities can be reduced further. So steel structure, this was attached to the building from outside, welded connections in precast embed, option of painted panels itself. But what will take equivalent block work of about 3 days, including your plastering, painting, in about 20 minutes, we are able to attach this panel to the structure and move forward. Right? And then there is no issue of plastering, seepage, joints, and all that. It's a solid, I think, M40 grade above panel, concrete panel, which will work better. This is another interesting item we are now looking at is pre-finished toilets. So this was done about 4 years ago in one of our projects. What you see on the left-hand side, the fully finished unit is what is pictured on the right hand side. So all that finishing equipment, including the appliances, sanitary fixtures, is already there in that toilet pot. Then it was placed in the building and then the surrounding building was built. Why? Because we spend a lot of time in finishing toilets at different levels. Multiple gangs have to go at different. It is very difficult to track and monitor the quality. Here everything is done at factory, monitored quality, and then sealed one, except the outside door, sealed one goes, and then you don't have to worry about the sideways. Same for commercial buildings. We have done larger toilets also. Again, whatever you see on the right hand side is already there in those toilets, finished in factory under extreme quality control. Right. So how do we build? We call it temporary factories. We don't have central factories. Transportation challenges, infrastructure is improving. So in few years, we'll have better roads where we can put central factories. But currently, our model has been using site-based factories. We call them temporary factories. But by no means they are temporary, right? You see, this is one of the latest factories I've been. It's like a full-fledged operating factory with covered shed and all possible equipments and everything. Let's see, inside out, it's a fully working, full-scale quality control setup. Just that at the end of the factory life, which is usually 2 to 3 years, we probably have to demolish and take it up to next place or whatever. So hopefully that also changes where centralized factories will become more mainstream. And then it will even if affect the acceptability, adaptability, even it will impact the costs. We do a lot of work where most of it is done indigenously in-house molds. But at the same time, if you remember, we talked about mechanization we are doing. So this is in that new factory is one of India's first fully automatic battery mold. Right. So this is used for vertical casting. If you will see these cells, if you see my pointer, they opened up, you put your reinforcement cage ready and all and close the cell. It is hydraulically operated, closed. It has its own vibrator system. It has its own curing system. And then about 80 panels can get poured together. They will get poured. How is, if you see this green setup is, this has a one funnel. And if you see this track on the left hand side, one concrete shuttle comes from the batching plant, taking the freshly mixed concrete. Under 6 minutes, that concrete is poured in this Comcaster to the battery mold. So one of our biggest quality control challenges is your transit mixer. You don't know when that concrete was poured, how long it has been mixing, rotating. It becomes very tricky to monitor the quality and track it. Here, there is no manual intervention in between. From my factory-based batching plant, as soon as the mix is done, it is directly dumped into the shuttle. The shuttle brings it, dumps it to the Comcaster. Comcaster places it into the panels in about 6 to 10 minutes, right? And then it automatically vibrated, cured, and get it. And this is what you get out of it, right? You get both side finish, mold finish. These are solid 8 mm thick plates, panels with good edges, everything. There is no joint marks and all. What you see, the mesh is just a temporary because it's the moisture. The panel was taken out immediately, but you get good finish, no formwork marks. And later I'm going to show you something on the mechanization plastering side. But because of this good finish, we can automate the plastering, right? So wall panels, automatic casting we have done. Next was steel tying, which is very workforce intensive activity. So we are looking at now tying the steels cages using robots, right? And we are in the advanced stages now. If you can see, we are already having like a proof of concept done where these robots are tying the steel, right? And productivity is good, where we probably 50 people work can be done. The robots will work in both shifts together. This is that automatic painting and sanding machine. Now, because we are using precast and that battery mold good finish panels, you can automate the sanding and painting because there is not much work involved, no lot of manual intervention needed because the surfaces are already good. So now this we have these two robots which will start another few days, which will they start doing this painting sanding activity, right? So this is where actually the whole precast system, just a quick flavor. Uh, Now, if I go to the digitalization side, this is a year and a half old picture, but if you see, this is what we are building, right? Mass housing. In this project, when I said about 7,500 units, we have about 1.2 lakh elements, the panels, the walls, the slabs that gets installed, right? So the olden days of tracking, monitoring manually in Excel spreadsheets are gone. Right? I have no option. It's not luxury, but I must use BIM. I must use digital ways so that I can track it. I can see what everywhere is and plan it better. Right? And that is what we have been again last 6-7 years, especially for precast. We have adopted BIM options where we are building central BIM models. It is mandatory on all our projects now to adopt BIM. And that model, of course, you see this various entities that I've listed here. They're specific to precast, but yes, it can be for any project. But there is design engineer, there is client, there is my business unit, there is factory, there is site team and a planning seal, and all they are using. Now, BIM, of course, is not new. Everybody must be aware of it. But those interfaces, various at central level is happening. It is improving a lot, where we have our own precast app, and that precast app tracks it. So this is where it starts the entire model itself is built. We have very specific tools now. Revit also has come a long way, but last 7-8 years we have been using to generate this for precast, right? Now this, what you see in picture, is 95% directly generated from that BIM model, including your reinforcement detailing. The down left, the down is my mold drawing. So we are using the generating the mold drawings also through this BIM model. So again, I noted about the concrete. There is much less manual intervention from batching plant to shuttle to mold. Here it's BIM to mold drawing to shop drawing and fabrication. Much less manual intervention, which is where the errors will happen. The dimensions or this, that, and all. You perfect your BIM model and everything is linked. Productivity is one, but the errors are also much less. Now, even a 6 mm link is modeled. The quantity control is better. Quantity takeoffs are better. We are able to generate that quickly. The joint grouts, lot of precast is very complex system, right? It's not just pouring concrete and steel. We have to do how many couplers are there, how many specific connectors are there, how many joints are there, what is the joint grout quantity and all. There is, if a cast in place BOQ will have 10 items, precast BOQ will have 50 items. So that gets tracked well. Once we have that system, I mentioned about 1.2 lakh elements. So we have now developed our in-house app where each of those 1.2 lakh elements are being tracked. Right, we have that ability where there are QR codes, and when that each element was cast, when it was demolded, at what strength, who signed off the checklist, where it was stored, for how many days it was stored, what was the strength when it left the factory, where is on the factory, to how many are there in the stockyard, how many are installed, how many I need to install, everything is getting tracked. Now in these days, again, the AI days now is drastically changed from last year. So this may not sound as fascinating, but in construction still what we are looking at is real time, right? What used to be a method where I'll do a spreadsheet, somebody will at the end of the day will update that spreadsheet and update the report. Next day it goes to the next level manager. He or she will look at it, publish it. By the time the key stakeholders or client gets to know, it is 1 or 2 days gone. But here everything is now, the option is real time, where the site engineer will scan the QR code and say this panel was installed. Everything is getting updated centrally. And if you see, we have this digital twins now. So yellow means it's in the factory, green means it's installed. So moment that engineer clicks it, scans it and says install, the model which is shared with all gets that update, reports are ready, and that's how we are able to move faster. Another this thing we are using in now digital is the concrete maturity meter. It's an olden system, but now getting mainstream is and especially works good for precast is strength prediction. Right. So precast is all about speed and efficiency. The quicker I take out my panel out of the mold, the quicker I can do the next panel. That's how that efficiency cycle time works. So this maturity meter sensors are there, which will give me the strength indication real time again. You have your phone, I'm showing that on the right hand side. And every minute, every 10 minutes, it will update saying now your concrete has gained 6 MPa, 6.6 MPa, 7 MPa, where our engineers now have that ability where you give the design strength. Like as soon as the panel hits 15 MPa, you can lift it, take it, store it, and start your next activity. Right? Cast in place is slightly different. You de-shutter it and all. There also time is of important, but it, in terms of days. So 7 days, okay, 7.5 days. Here in terms of hours. So even if I save 2 hours in that panel lifting, shipping it, it makes a big deal, and that we are able to do that real time. And accordingly, we have a bunch of applications environment that is working around for precast, and we are known for that digitalization. Everything is in house, but including the stores to get the material to site, to what each mold is doing, how many times it's repeated, what each equipment is doing, the asset insight. Conquer is our quality app. For workmen, we have this visa app where all there, how many are there, what was their background, what is the experience, everything is there. Advanced tools wise, of course, you see this Trimble SX12, which is of interesting. We have been using it for a couple of projects now, where all your surveying needs, digitalization needs, levels, misalignments, dowels. If you see this right hand side top picture, precast has dowels, and those are extremely sensitive. We are tracking at almost plus or minus 3 millimeter. Otherwise, the next panel would not fit. And here in one scan, we are able to see what my BIM model is and what my actual dowel is and how much is the deviation, or if I need to do anything, which earlier we used to do at each dowel, we have to go and survey and measure and then do. This is happening much faster level. Right. So with that, of course, these days we cannot move forward without sustainability. And of course, Ishan mentioned about one of the biggest advantage now in precast is of course the dust and pollution control. And if you see China, Beijing or Shanghai, they have banned regular construction in the main city area. You have to do it off-site construction, either steel or precast. If you see Singapore, that is, they have been doing it for a long time, where you can't do anything or as much as possible off-site, and we are moving there. But in general, also beyond that, if you look at these technologies or digitalization, how in my mind they are helping, the lowest hanging fruit is just wastage reduction, right? And we are still in that construction phase where there is huge amount of wastage all around. Actual, advertent, inadvertent, but still wastage is there, right? And these technologies, digitalization or precast technologies, one of the biggest quick low-hanging fruits are wastage reduction in terms of not just material, but your drawing delivery, the digital tools, your planning, your material, your processes, everything. Even if that, as a growing and developing nation aspiring for the Vikasit Bharat 2047, if we use these to see, that itself is a big help. And how we have done also, just one quick example and then I'll conclude. what we have done in the past is my steel wastage used to be about 3 to 4%, and that's a very standard norm. Sometimes it's even higher. But we have tracked now a 2 year long wastage of steel in the precast factory, and it came to about only 1.5% at the max, usually on an average percent itself. Where in my ongoing tenders, we have started now, if it's a precast factory, steel percent is 1%, right? That's my way saying, okay, now I can justify the technology, I can reduce the cost somewhere, we can start showing that cost benefits. Of course, that will get passed on to the client, and that's how these technologies will evolve. So with that, I will conclude. We have one quick video of that Mission 96 building. I thought it will be of interest to everybody, see how that building was done and evolved. It's about 3 minutes long, but it kind of covers both precast and this digitalization theme. And after that, all right. So with that, thank you again. Thank you very much for your patient hearing. And yeah, I think Ishan, we can go ahead with the question answer.
Thank you so much, Amit, for sharing your experience. It was really insightful and engaging.